Hey everyone, and welcome! Today, we're jumping into a topic that, honestly, every single Python developer needs to have locked down: Unicode. Yeah, I know, it sounds a little dry, but trust me, understanding this is absolutely the key to writing solid, global-ready software, and, maybe more importantly, to acing those tough technical interviews. So, let's get right to it.
So, have you ever seen this? You open a file or you load a web page, and you're greeted with this complete mess of weird symbols and question marks. It's so frustrating, right? This garbled text, which is sometimes called mojibake, happens when a computer just gets its wires crossed about how to display characters. It's a classic problem, but lucky for us, there's a fantastic solution.
And that solution is Unicode. The easiest way to think about it is like it's the United Nations for text. It's this one universal standard that gives a unique number, we call it a code point, to every single character from every language on Earth, and yeah, that includes emojis. What this means is your computer doesn't have to guess anymore. It has a single definitive rulebook for understanding text.
So here's our game plan for today. We're going to quickly cover what Unicode is, then we'll dig into the key concepts you need to know for Python. We'll see it in action with some real code, and then we'll shift gears to how you can use this knowledge to nail your interview and really shine on the job.
All right, let's start with the basics. To really get a handle on those weird text problems, we first need to understand what Unicode actually is, and why it's so fundamental to just about all modern software.
Now here's the best part for us Python developers. If you're using any modern version of Python, so Python 3 and up, you're already using Unicode. It's the default. It's baked right into how Python handles strings. This makes working with text from different languages incredibly easy, because Python was basically designed from the get-go to speak every language.
Okay, so let's pop the hood and look at the mechanics. To really get good at this, there are a few core concepts you just have to know. Think of these as the building blocks you'll use for everything from fixing bugs to explaining your skills in a job interview.
The whole thing really boils down to three main ideas. First, you have a code point. That's just the unique number for any character, like the copyright symbol. But computers don't really think in characters. They think in bytes. That's where encoding comes in. It's the process of turning that string of characters into a sequence of bytes that can be saved in a file or sent across the internet. And you guessed it, decoding is just the reverse, turning those bytes back into a string we can actually read.
Let's just hammer this home because it's super important. Encoding takes your nice, readable string and turns it into bytes. You do this when you write to a file. In Python, that's the .encode method. Decoding takes bytes, maybe from a file or an API call, and turns them back into a string you can work with, and that's the .decode method. They are perfect opposites. Getting this distinction right is probably the single most important part of handling text correctly.
Now, beyond those basics, there are two more concepts that are just vital when you're on the job. First up is normalization. You know how sometimes two characters can look exactly the same but are actually different to the computer? The word café is the classic example. Normalization makes sure the computer sees them as the same thing. And second, error handling. What do you do if your code tries to handle a character it doesn't know how to? It could crash. Using error handlers makes your code way more robust.
Okay, theory is great, but let's see what this actually looks like in Python. This is where you'll see how these ideas come to life and just how powerful they are. One of the simplest ways to work with the Unicode character is using its escape sequence. Here we're using U00A9. That's just the code point for the copyright symbol. Python sees that little code and just knows to print the right character. Super simple and super effective.
You can also go straight from the number to the character. The CHR function is your friend here. It takes a number, in this case the hexadecimal value for the grinning face emoji, and bam, it gives you back the actual character. It really shows you that direct link between the number and the symbol.
And here we go, encoding in the wild. We start with a normal string that has some text and an emoji. When we call .encode UTF-8, Python turns it into something called a bytes object. You can always tell it's bytes because of that little B out front. See how the emoji turned into that weird sequence of hex codes? That's because it takes more than one byte to represent it.
Okay, now check this out because this is where normalization is just pure magic. We've got two strings here, S1 and S2. To you and me, they look identical, café. But to the computer, one is a single character and the other is the letter E followed by a separate accent mark. So when we first compare them, Python says they're false. They're not the same. But After we normalize them both to the same standard form, the comparison correctly gives us true. This is so incredibly important for things like search bars or password checks.
All right, so you get the mechanics. Now for the payoff. How do you take all this knowledge and use it to really impress a hiring manager and ace that technical interview? When you're in that interview, these are the points you want to hit. You want to confidently explain that Unicode is the universal standard. You want to mention that, hey, Python 3 makes our lives easy by making it the default. Then you cleanly explain encoding versus decoding. And for bonus points, you talk about why normalization is so critical for user input and how you debug a common Unicode encode error. And this quote right here, it just nails it. When you can talk about Unicode with confidence, you're not just showing you know some Python syntax. You're showing that you're a serious, modern developer. You're showing that you think about how to build software for a global audience and how to make it robust and easy to debug. It's a massive green flag for any employer. And once you've landed that awesome job, this isn't some abstract theory you can just forget about. I promise, Unicode is something you are going to see and use pretty much every single day. Let's look at a few examples.
If you're in web dev, you absolutely need it for internationalization, making your site work for anyone, anywhere. For data folks, getting encoding right prevents data from getting corrupted. If you're working on a search feature or a login system, normalization is your best friend for making sure things work as expected. And really, for everyone, it's a huge part of debugging logs, databases, and building UIs that can handle anything a user throws at it.
So here's a simple little checklist that will save you a ton of headaches. 1. Make sure your whole environment, your editor, your terminal, is set to use UTF-8. 2. Always be explicit about the encoding when you open a file or make a network request. 3. Normalize any text that comes from users. And 4. Use error handlers so your app doesn't just fall over when it sees a weird character. So we'll wrap up with this question to chew on. Unicode has solved so many of the problems we used to have. But the digital world just keeps growing and getting more connected. As our software reaches even more cultures and people, what do you think the next big challenge in representing human language and symbols will be? What's the next thing we, as developers, are going to have to figure out? Thanks so much for watching.